Welcome everyone. I'm going to try and finish up the lecture from last week in this video, trying to keep myself on task just a little bit here. So we left off, I kind of skipped around at the end because we were really fighting against hitting the wall. But we left off talking about how we could handle hazardous waste. And so hazardous waste by definition are more dangerous than regular municipal solid waste or trash that we throw out. So much like many of the other things that we've looked at this year, the best way to handle anything is to do a lot of different things, but not do a ton of any one thing. So, much like we've talked about in most of this lecture, we need to reduce, reuse, and recycle. And if we can convert these things to less hazardous substances, if we can make them slightly inert, if we can make them less radioactive, if we can chemically alter them in some way to make them less harmful to the environment, then we should probably do that. And then ultimately, some of it should go into long-term storage, and we've talked about some of the challenges that go along with that. So I need to get my face back up here. So when we talk about detoxifying, we're talking about trying to make it less dangerous. So sometimes we can physically separate things. Like think about the sludge project that you did for me in Chem 1. We did most of this stuff. Maybe not the bottom couple, but we did several of these things. We physically separated solids from liquids, and then chemically we can separate things. That's a little bit more involved, but we certainly can do it. We could use magnets or even nanomagnets to try to pull metals and really any kind of charged particle. So ions could be attracted by strong enough magnets and things along those lines. So it depends on what the hazard is. But sometimes perhaps we could use magnets. And then bioremediation, phytoremediation, I think I want to show you on this slide. So when we talk about phytoremediation and bioremediation, we're talking about letting life kind of fix the problem for us. So you can see here in this picture, and I know even in the video it's really small, but what's going on here is we're using plants, specifically sunflowers, willows, and poplars, to kind of suck up some of this radiation. This is supposed to be an area that's been contaminated with radiation. So there's something about sunflowers that can detoxify the soil and can absorb some of that radiation, so it maybe doesn't get passed on to other people or other organisms. Sometimes there are animals or specifically plants. I don't know why I said animals. Sometimes there are plants that can pull things like heavy metals out of the soil, like if there's a big buildup of aluminum or something along those lines. Often there are plants that need a lot of aluminum in their diet, and or whatever the metal might be. But we can plant different plants. You see mustard and ferns here are some that can pull out some metal contaminants. But again, phyto and bio are both different ways of using life to go about kind of purifying soil, purifying water, purifying air naturally. So there also are wastewater treatment facilities that are basically like a big swamp, and they pump the waste out into a wetlands, and gravity takes over and the solid filters down to the bottom, and then the liquid kind of gets pumped throughout the wetland, and as plants draw it up and use it in their life cycle, they purify and filter the water. So the water that comes out is really clean compared to the stuff that goes into the system. So we've talked through most of this long-term storage stuff because I wanted to hit on the landfill pieces last time when you were in class. So last thing I need to really hit on is the laws that regulate trash and hazardous waste and all these kinds of things. So we use acronyms for these. RCRA is Resource Conservation and Recovery Act. Basically says we should be considering cradle to grave. You see here the EPA sets standards and gives permits for having hazardous waste, possessing it, using it, producing it, those kinds of things. But as you can see there, it doesn't cover all hazardous waste. It only covers kind of the most dangerous of the hazardous wastes. So it was enacted in 1976, so it's certainly not anything new there. And then CERCLA, Comprehensive Environmental Compensation and Liability Act. You saw that when we talked about mining in the documentary we watched. They talked about CERCLA a few times. You see that there is a priorities list that in 2010 there were 1,300 sites. That 340 sites was true as of last year, I think. I haven't looked that up this year. Part of that's because the Superfund doesn't have so many funds anymore. And then you see down here that it talks a little bit about brownfields. Brownfields I've mentioned in class before without maybe naming them, without using that term. What we're talking about with a brownfield is a place that is polluted and we can't use it. So an example of that might be if there's a gas station that has been open for maybe any number of years, and they didn't realize that the tank underground was leaking. Then that could leak into the soil and into the water, and that whenever the company that owns it goes to sell it, they aren't going to be able to sell it because the ground won't pass inspection. So that's what's often called a brownfield. It's so polluted that it can't pass any sort of inspections to be sold to someone else or anything along those lines. And you see CERCLA was enacted in 1980. We've talked about NIMBY, not in my backyard, and we've talked about trying to reduce, reuse, and recycle. Kind of the last kind of pieces here on laws. These are international treaties. The Basel Convention, some people I think would say that Basel. I don't know. I'm a hillbilly from Lebtuck, so I say Basel. So in 1992, it was like an agreement that said we're gonna reduce our hazardous waste. And then you see in 95 we said, okay, not only are we gonna reduce our hazardous waste, but we're not just gonna ship it off to other people. Like we're kind of being dishonest in saying that we don't have as much because we're shipping it off to less developed countries and making them kind of deal with it. Then in 2009 there was an update. And then it was ratified in 2009 by 195 countries. We didn't ratify it. We did agree to it. Difference there is when something is signed, that means that some representative of our government has signed the document. Typically, that means the Secretary of State, but not always. If it's ratified, that means that it's passed Congress. So elected officials have voted and have made a formal law. So we've agreed to it, but we've not ratified it. And that's been the case with many of our environmental policies that we've looked at this year, the international ones specifically. In 2000, we talked about the dirty dozen with persistent organic pollutants. I hit on that on another lecture. So you should be in good shape, hopefully, on that one. And then this Swedish parliamentary law, if I remember right, was adopted by most of the European Union. And they were trying to ban all POPs by 2020. Spoiler alert, that didn't happen, but we tried. So I talked a little bit about my biomimicry in the course of talking about, wastewater treatment facilities and things along those lines. So kind of my moral to the story is reduce, reuse, recycle is an easy, we've kind of had that programmed into us for a long time. So we're probably pretty comfortable with reduce, reuse, recycle. And then the big takeaway with all of this trash stuff is we have to use some sort of integrated waste management, so we're not dumping a ton of trash here or a ton of trash there or a ton of trash there or in the water. We need to put a little bit of it here, a little bit of it there, a little bit of it here, and we need to dispose of it in as responsible a way as we possibly can. There's no such thing as away. Like, you can't throw something away. Like, you can put it in a trash bin, and then it goes into a bigger trash can, and then it goes into a dumpster, and then it goes into a dump truck, and then it goes to a landfill. But it's still somewhere. There's no getting rid of things. The law of conservation of matter says if it's here, it's going to be here forever. It may be in a different form. We might be able to switch it from one thing to another, but it's here. So things that are like microplastics and e-waste and all these kind of modern issues that we're facing, they're really starting to be problems now because these things have existed long enough for them to start to accumulate. As technology continues to advance, hopefully we can find ways to reduce our trash stream faster than we're increasing it. So that's kind of, I'm getting off on a soapbox here, so I want to kind of leave off there. Please let me know if you have any questions about trash or hazardous waste or integrated waste management. Thank you.